Hello my dear students of B.Sc third semester. So in the previous lecture we have studied about the Maxwell's Boltzmann distribution law for an gas in equilibrium. Now in this lecture we will study about the Maxwell's Boltzmann distribution law for molecular speeds, and these are the formulas of integration which we have to use in this expression for molecular speeds. Clear? So in the start we must know about the occupation index, and in the previous article we have studied that occupation index, that is the ratio of number of particles to number of cells. So that is Ni upon Gi, that is equal to e raised to power minus alpha e raised to power minus beta ui. Yeah? Or you can say Ni is equal to Gi into e raised to power minus alpha e raised to power minus beta ui, where Ni is the number of particles or number of molecules in a gas, and Gi is the number of phase space cells, and alpha and beta are the constants, and u is the energy. Clear? Now we know that the particles or molecules are moving in a gas and they have momentum and energy both, and there is a relation between the kinetic energy and the momentum of the particles or of the molecules, that is equal to u is equal to p square over 2m. We know that this is a relation. Now if we want to find out the number of molecules between the momentum interval p and p plus dp, between the momentum interval, or you can say between the momentum p and p plus dp, then the number of molecules between the interval or between the momentum p and p plus dp. Now between p and p plus dp, this n changes to np dp, because the interval is now dp. Momentum is between p and p plus dp. So np dp, p stands for momentum. Here this is equal to gi. Gi goes with gp dp. Here gp dp upon e raised to power alpha into e raised to power beta u, and instead of u we write p square by 2m. Now we have changed this expression into momentum terms. Clear? Now to find out this number of molecules between the momentum p and p plus dp, we must know about gp-dp, and gp-dp is the number of phase space cells between the momentum p and p plus dp. So how we can find out this gp-dp? We have studied in the start of this chapter about gp-dp, that is the number of phase space cells, that is equal to the volume in the momentum space, total volume, you can say total volume in the phase space divided by volume of one elementary cell, and total volume in the phase space, that is equal to, yes, that is equal to dx, because the phase space is a combination of momentum space and position space. So for position space we have volume dx, dy, dz, and for momentum space we have dpx, dpy, dpz. So this is the volume of the system in the position space, and this is the volume of the system in the momentum space, divided by the volume of the elementary cell, and that is equal to h naught q. That is equal to h naught q. Clear? Now dx, dy, dz, this is equal to v. We know this is equal to v. So this is equal to v into integration of dpx, dpy, dpz divided by h naught q. So this is the value of gp-dp. So to find out gp-dp, we have to solve this integration. How can we find out this integration? This integration means the volume of the system in the momentum space. So to find out this value means to find out the volume of the system in the phase space, we have to take two concentric spheres, one having volume, one having radius p and other having radius p plus dp. So we take two concentric spheres, one having radius p and other having radius p plus dp. So this is you can say momentum space, and this is say px, py and pz. So two spheres, this single inner sphere having radius p, so this having radius p, and this upper sphere, this having the radius p plus dp. So if this is p and this is p plus dp radius, then what about this? This is dp. This is thickness dp. Now this integration dp x, dp y, dp z. So volume of the molecules or volume in the momentum space or in the momentum interval dp or between the momentum p and p plus dp, that is dpx, dpy and dpz. So this is equal to this is the volume. So this is equal to the surface area of the inner sphere. Pay attention, surface area of the inner sphere, and inner sphere have radius p. So surface area for inner sphere, that is 4 pi p square into this thickness, that is dp. So this is the volume. Clear? So put the value of this volume here. You will get the number Gp dp, which we want, Gp dp, and then we put this value in Np dp. So this implies Gp dp, put here Gp dp, that is equal to V into 4 pi p square dp divided by h naught cube. So this is Gp dp. So put the value in this expression Gp dp. So this implies Np dp, that is equal to, yes, Gp dp 4 pi v p square dp divided by h naught cube into e raised to power alpha, e raised to power beta p square, this is beta p square by 2n. So alpha, beta term, h naught cube, from here 4 pi v p square dp, where v is the volume. Clear? Now from this our aim is to find out alpha and beta from this equation. How we can find out alpha and beta? So for this we take this equation as equation number 1. Take this equation as equation number 1. If this is equation number 1, yes, then let's consider that there is a consideration on the number of molecules, that number of molecules have maximum value, that is equal to n, between when momentum is p maximum, and or you can say when p is p maximum, starting value is 0 momentum and maximum value is p maximum momentum's value. At that time n is equal to number of molecules, that is equal to 0 to p maximum. 0 to continuous values means 0 to p maximum. And let's take the value of p maximum, that is no you can say molecule have momentum more than p maximum, and its maximum value is p maximum, and it is maximum कितनी हो सकती है, वो तो infinity, that is approaches to infinity. So limit is here 0 to infinity 4 pi v p square dp divided by h naught cube e raised to power alpha e raised to power v square by 2n. So the constant terms take outside. What is constant? 4 pi V, that is constant. From here h naught cube is constant, e raised to power alpha is constant. We have 0 to infinity p square over e raised to power beta p square by 2m. Take it upwards. So e raised to power minus beta over 2m p square. Clear? Divided by h naught cube. H naught cube is outside. So h naught cube is here. E raised to power alpha is outside. 4 pi v is outside. Only the terms containing p, that is in the invert this integration into dp. Now this is a standard integration, and I write here the formula. I write again 0 to infinity x square e raised to power minus a x square, that is equal to 1 over 4 pi over a cube. So CTM, carry to memory this. This is the formula which we have to use in here. Clear? X square is p square. E raised to power a is beta over 2m here. Clear? So this is equal to 1 over 4 pi over a cube raised to power 1 by 2. So when we use this formula here, what you get, n is equal to 4 pi v upon h naught cube e raised to power alpha. Yes, 1 by 4 pi over a cube. A is beta by 2m. Beta by 2m cube raised to power 1 by 2. So I put only 1 by 4 pi over a cube. A cube is beta by 2m cube raised to power 1 by 2. Now 1 pi is here. Pi 1 by 2, pi 1, pi 3 by 2, and it is already 3 by 2. So this is equal to 4 pi v upon h naught cube e raised to power alpha. Take pi out in the bracket. Excuse me. Yes, this is pi 2m divided by beta raised to power 3 by 2. So 2m upward 2m pi upon beta raised to power 3 by 2. So this is n. Now find the value of e raised to power alpha from this and put here. Find e raised to power alpha from this and put here. Yeah? So write down, put the value of e raised to power alpha from this equation. Yes, find out e raised to power alpha from this equation. So from this equation, what about e raised to power alpha in this side and goes here, or you can say 1 over e raised to power alpha. So we have n is this. So 1 over e raised to power alpha is this. Raised to power 3 by 2. Raised to power 3 by 2. And this is 4. This is 4. Right here. 1 by 4, because we forget this 4. 4 goes with this 4. So here is not 4 cancelled out. So this is 1 over e raised to power alpha. That is n h naught cube upon v. Here beta over 2 pi m raised to power 3 by 2. This is equal to 1 over e raised to power alpha. Now put this value of 1 over e raised to power alpha in this equation. So put here. I put here, this is equal to 4 pi v p square dp upon h naught cube e raised to power beta p square by 2m. Yes, put 1 over e raised to power alpha, that is equal to n h naught cube upon v beta over 2 pi m raised to power 3 by 2. Raised to power 3 by 2. n h naught cube on. Okay? We have put all this. I rub it now. Now I solve this. The terms which cancel out will be h naught goes with h naught. V goes with V, and we have that is equal to 4 pi upon, now e raised to alpha term goes, so e beta, because our aim is to find out alpha, means e raised to alpha we find out, so from that you can find out alpha. So now beta p square by 2m 4 pi n, that is p square beta, this is beta upon 2 pi m raised to power 3 by 2 into p square dp, into p square dp, 4 pi n beta over 2 m raised to power 3 by 2 p square dp. So this is our NPDP now. Now this is the number of molecules between the momentum interval dp, or between the momentum p and p plus dp. We have removed alpha from here. Now only we have beta. So now our aim is to find out beta. So how can you find out beta? How can you find out beta? So for beta, first convert it in the energy interval. It is a number of molecules in the momentum interval. Now we convert it into the momentum in the energy interval. So for this we know the relationship between the momentum and energy, that p square by 2m, that is equal to u. So we know that u square u is equal to, I write here, this is NP dp. Now I write here, we know that u is equal to p square by 2m. So from this differentiate it with respect to p. So du upon dp, that is equal to 2p upon 2m. So 2 cancels with 2, p over 2m. So from this, what about p? P square is equal to 2mu, and p is equal to under root of 2mu. So put here p is equal to under root 2mu divided by m. Clear? So this is m1, this is m1 minus m minus 1 by 2 downward, because this is 2u under root divided by m, because this is m1 minus 1 by 2, that is equal to minus 1, that is equal to 100. So put the values, convert it, this now nu du, that is equal to 4 pi n upon e raised to power. Now p square by, where there is p, convert it into u. So beta into p square by 2m. So put beta into u here. Now beta over, this is beta over 2 pi m raised to power 3 by 2. P square is 2mu. P square is 2mu. And what about dp? What about dp? And dp from this, what about dp? Yes, convert dp du into under root of m upon 2u, that is equal to dp. So put the value of dp, that is equal to m upon 2u into dp. So solve this, we will get mu du. After solving this, we get this. Yeah? After solving this term, we get this. Now this is nu du. Yes. Now we have to find out the value of beta. How can you find out the value of beta? So to find out the value of beta, we use the law of equipartition of energy. Which law? The law of equipartition of energy. So according to law of equipartition of energy, we have the energy of the system, or energy for one molecule, that is equal to 3 by 2 nkt. N particle nkt, for one, that is 3 by 2 kt. Clear? 3 is the translational degrees of freedom. Half kt multiplied by degrees of freedom, that is 3. So according to equipartition of energy, U is equal to 3 by 2 kt. And if we have n molecules, then we multiply it by n. This is the total energy. This is the total energy. Now this is also the number of particles between the energy interval u and u plus du. So to find out the energy from this energy must be equal to, you can say that is equal to 0 to infinity nu du into u here. So this is, put the value of nu du here. So this is 3 by 2 n kT, that is equal to nu du, that is equal to 2n, that is constant, under root pi, that is also constant, beta 3 by 2 u raised to power 1 by 2, that is inside, u 1 by 2, this is u 1 by 2, this is u, so u becomes 3 by 2 e raised to power minus beta u du. So this you get from this, where that is beta, this k is equal to 1.38 into 10 to the minus 23 joule per Kelvin. You know the value of k. Yes. So this is also a standard integration, and its formula is u raised to power 3 by 2 e raised to power minus beta u du. So we use this integration formula, 0 to infinity x raised to power 3 by 2. Instead of x, here is u. X raised to power 3 by 2 e raised to power minus ax. A is here beta. Dx, that is equal to 3 by 4 a square pi over a raised to power 1 by 2. Pi over a raised to power 1 by 2. So put the value here, 2n over under root pi beta raised to power 3 by 2. Yes, 3 by 4 a square, a is beta, beta square, yes, pi over a is beta raised to power 1 by 2. So when you, this is equal to 3 by 2 n kT. So n goes with n goes with n. So this is beta 3 by 2. This is beta square. This is beta 1 by 2. Beta 2 plus 1 by 2. Beta 2 plus, this is beta 3 by 2. Here is beta 1 plus 1 by 2. Beta 1 plus 1 by 2 is beta 5 by 2. And this is beta 3 by 2. So all other terms will cancel. 3 goes with 3 here. 3 goes with 3. This 2 becomes here 4. This 4 goes with this 4. This under root pi goes with this under root pi. So from this you will get beta is equal to 1 over, this is kT, 1 over kT. Because this becomes beta 2 plus 1 by 2, that is beta 5 by 2 and beta 3 by 2. Yeah? So beta 5 by 2, beta 3 by 2. So from this you will get beta is equal to 1 by kT. So beta is 1 by kT. So we have used so many times beta. So from this Maxwell's distribution law, we get beta that is equal to 1 over kT. Clear? See? Now put this value of beta is equal to 1 over kT in this equation, nu du. Put here. So beta is equal to 1 over kT. Put here. You will get nu du, that is 2n upon under root pi, that is equal to beta raised to power 3 by 2, means 1 over kT raised to power 3 by 2. We know k is equal to 1.38 into 10 to the minus 23 joule per Kelvin. U raised to power 1 by 2 e raised to power minus u over kT du. So this is our number of molecules between the energy interval u and between the energy u and u plus du. Our interval is du. Now if you convert into speeds, you can also, because we have to find out the Maxwell distribution law for molecular speeds. So for molecular speeds we have u energy, kinetic energy, that is equal to half mv square. Half mv square. So from this you will get where there is a u, you can put here half mv square, and v we want du, so du upon dv, that is equal to half m into 2v. So 2 goes with 2. So from this du is equal to mv dv. So du is equal to mv dv. So where there is a half mv square, so that is equal to derivative with respect to, when we differentiate it with respect to v, we get half m 2v. So from this du is equal to mv dv. So where there is a du, you will put the value of this and you will get the value, this is nu du, and you will get in terms of, you can write v like this, okay? You will get this in terms of v, and this becomes mv dv, that is equal to under root, the result will be, I remember that result, 2 pi n m over pi kt raised to power 3 by 2 e raised to minus beta u e raised to minus mv square upon 2 beta is kt v square d. So this is the Maxwell's distribution for molecular speeds, under 2 pi n pi over m over pi kt raised to power 3 by 2 e raised to minus m v square upon 2 kt v square dt. And when you have a graph between this nv upon n, when you write here nv dv, we will explain in the next lecture. It just I draw it here, and here is v square. You will get the graph like, not a graph is like this. Yeah, this is the maximum value. So first, like a parabola, first increase then decrease. So this is the graph. We will explain in the next article most probable speeds and other two speeds and the graph. Thank you.